Okay, good morning. Welcome to FAPESP for the Brazil-France Health Workshop, Frontiers of Global Health, collaborative efforts between Brazil and France. And to open this event, I'd like to invite the President of FAPESP, Professor Marco Antônio Zago, the Consul General of French General Consulate in São Paulo, Mr. Yves, Madame Sophie Jacquel, Deputy Counsellor for Cooperation and Cultural Action of the French Embassy in Brasília, the Administrative Director of FAPESP, Professor Fernando Menezes, and our Scientific Director, Professor Márcio de Castro Silva, Filho. Please. We now give the floor to Professor Marco Antônio Zago, the President of FAPESP.
Ok. Ok, bonjour, bon dia. Good morning. Welcome to FAPESP. Monsieur Yves, Teyssier, French Consul General here in São Paulo. Madame Sophie Jacquel, Counsellor of the French Embassy in Brasília. Márcio de Castro Silva, Scientific Director of FAPESP. Fernando Menezes, Administrative Director of FAPESP. And yes, dear colleagues, I am very glad to open this workshop on research cooperation in medical sciences and healthcare between France and the State of São Paulo. This meeting was planned during our visit last year to French universities, hospitals, and research agencies, and will probably be followed by a similar workshop. Probably no, it's sure it will be followed by a similar workshop in France next year, which will be part of the commemoration of the Brazil-France year. The objective is clear. The aim of this meeting is very clear. Is to exchange information about the present state of health research in the two regions, France and São Paulo, and explore the opportunities for researchers and research teams to know better one another so that they can apply jointly for funds for research projects. That's why we are here, is to talk and plan for research funds to carry on joint research. I'll show some slides. I think they are interesting. The research collaboration between France and the State of São Paulo starts as we have information around 1956. Research collaboration between the State of São Paulo and France is very strong and stable. For instance, in this period of 10 years, 2012 to 2022, there has been about more than 14,000 joint papers published between researchers from São Paulo and France. What is interesting is that research collaboration increases very much the impact of research papers. As you see at the right side of the slide, the papers, all papers published by the State of São Paulo in this 3-year period have an average impact of 0.94. And the international collaboration papers, that meaning papers that have co-authors from the State of São Paulo and some other country, the impact goes to 1.3. The same thing happens with France. All papers from France for this period have an impact, an average impact of 1.19. The international collaboration papers from France, 1.45. But when France and the State of São Paulo publish together, the impact is 2.86. I think, as I said, when the president of CNRS came here, it's good for us, it's good for you. So that's why we collaborate. When we look specifically in medical research, we see that although the collaboration is very old, it's after 2010 that we started publishing together more than 200 papers every year. And this is a balance of this. When we look at the medical science in this period of 5 years, you see that the State of São Paulo, the researchers from the State of São Paulo published more than almost 100,000 papers in this period in the medical science, with an impact of 1.18. But São Paulo and France together, they published almost 3,700 documents with an impact of 5.71. And 18 of those papers included some kind of cooperation with companies, with business. And in this case, the impact was 13. This is a balance of the sponsors of those 3,700 papers. FAPESP, CNPq, NIH, because there were some triangular cooperation, CAPES, United States Department of Health, the European Commission, National Cancer Institute, Medical Research Council, Pfizer, ANR, and so on. As you see, FAPESP is the main funding research for this cooperation, obviously, between the State of São Paulo and France. It's not a balance of Brazil and when you look at where the researchers from these papers were, you see most of them were in the University of São Paulo, the other from INSERM, Unifesp, the Federal University in São Paulo, Assistance Publique, CNRS, Université Paris-Saclay, Pitié-Salpêtrière, INESP, Albert Einstein, Unicamp, and so on. The areas were mainly basic medicine and clinical medicine, mostly clinical medicine. And then other areas, complementary health science, medical biotechnology, and so on. And this is a cloud, a word cloud of the subjects of those research. And we put in green the areas in which the subject is growing, is increasing, and in blue, those which it is declining. But you see the most important topics of collaboration between São Paulo and France. Finally, there is an important point, is that many of those documents, those articles have been used as basis for policy documents for different policy bodies from 66 different countries. This means governments, intergovernmental organizations, think tanks, and so on. For instance, World Health Organization, PAHO, FAO, United Nations, OECD, World Bank, Public Medicine, Generalitat de Catalunya, and so on. There were 14% of those documents were cited of our publication, joint publication, were cited in these documents. And the impact for those articles is 20, the average impact. So, as you see, we have already a solid basis to strengthen our scientific cooperation. Both FAPESP and the French funding agents, such as ANR, INSERM, CNRS, are willing to support good projects. We need good projects, and this, fortunately, is increasing. We have received, both here, and we have talked to people from ANR, they also say that the quality, number of good quality projects have increased in the last years. I am sure that this workshop will be an opportunity to expand this collaboration and to start new partnerships. Finally, I should like to thank warmly all those that were involved in planning and organizing this meeting from our side and from the other side of the Atlantic. Thank you very much.
Thank you, Professor Zago. We now give the floor to the Consul General of the French General Consulate in São Paulo, Mr. Yves.
Dear Professor Zago, President of FAPESP, dear Professor Márcio, Scientific Director of FAPESP, cher Sophie, Jacquel, cher Fernando Menezes, dear all professors and researchers. Scientific cooperation between French researchers and Brazilian researchers in the state of São Paulo, as we saw right now, is going well, very well. I would like to mention two major recent achievements that tell everything. The creation of the Institut Pasteur de São Paulo and the International Research Center Transitions, which is between USP and CNRS. Most French universities and research organizations have cooperation agreements with Paulist state universities, USP, Unicampi, UNESP. And in this scientific cooperation is going well, if it is going well, it is largely thanks to the support of FAPESP, which knows how important it is for science to be international, to be carried out in international environments. The state of São Paulo has an amazing ecosystem of universities, national research organizations, and cutting-edge laboratories. This ecosystem is clearly one of the best in Latin America. When it comes to health research, France is clearly first-rate. The research organizations, institutes, and foundations dedicated to medical research are world-renowned for their excellence. INSERM, CNRS, Institut Pasteur, Institut Curie, Gustave Roussy, etc. University hospitals are also major players in research. In the state of São Paulo, health research is also very advanced, whether in the medical faculties of the Paulista state universities, the various research centers such as the Cellular Therapy Center and the Hemocentro, which Marion Alcantara from the Institut Curie visited earlier this week, and of which you, Professor Zago, are one of the main architects. Or I mention also the Butantan Institute. In short, there is great potential for cooperation of excellence between France and Brazil, and more specifically between France and the state of São Paulo. There are already a number of scientific Franco-Brazilian cooperations, and Sophie Jacquel will tell you more about them, but there is no doubt that we can do more and better, especially as healthcare is a priority for both our countries. I'd like to thank FAPESP for organizing this workshop and greet all the speakers, especially the researchers who have come from France to exchange ideas with their Brazilian colleagues and strengthen existing links or forge new collaborations. I will finish with a few more personal words. This will be probably my last time here in the FAPESP building, as I am leaving at the end of August to return to France. I'd like to say what a pleasure it has been to work with you, Professor Zago, and with you, Fernando. As I said, the last few years have been very rich in terms of scientific cooperation in the state of São Paulo. It made me really happy and satisfied for our higher education and research institutions and for the French and Brazilian researchers who work together. To conclude, I am delighted that this workshop is taking place on the eve of a ceremony tomorrow at the Résidence de France, at which the French ambassador will present you, Professor Zago, with the Medal of Chevalier de la Légion d'Honneur. It's quite a nice coincidence, these two events taking place one after the other. I wish you all an excellent event. Thank you.
I think we should take the opportunity to thank Yves Dauphin for all the work he has done here. Say that we'll miss him here a lot. And remember that during his stay here in São Paulo, we have a lot of very important achievements in the scientific relationship between France and São Paulo. I would remember the visit of President Macron to the Pasteur Institute. So finally, and under his direction, we finally inaugurated the branch of Pasteur Institute here in São Paulo. CNRS established a research institute here with strength at the moment. So we should, I think, thank Monsieur Yves Dauphin, please.
Well, we now give the floor to Professor Márcio de Castro Silva Filho, the Scientific Director of FAPESP.
Bom dia, bonjour, good morning. I would like to greet, first of all, Professor Zago, President of FAPESP, Monsieur Yves Teyssier, Consul General in São Paulo, Sophie, Jacquel, Deputy Counsellor for Cooperation and Cultural Action in France, Embassy in Brasília, my colleague Fernando Menezes, and also my colleagues in the audience. Welcome to FAPESP. As Professor Zago pointed out, the numbers between São Paulo and France are quite remarkable, which guarantees a very exciting and challenging future. And also what Monsieur Yves Dorfel mentioned just minutes ago, we have two very exciting examples of these achievements with the CNRS and Institut Pasteur having offices and laboratories in São Paulo, so highlighting the importance of this collaboration. So long live to São Paulo and France collaboration in scientific affairs. So, and I take the opportunity also to wish you all a very exciting event. Thank you.
Thank you, Professor Marco. I'd like to invite Professor Fernando, Mr. Dorfel, Professor Zago, and Professor Márcio to take your seat in the audience for our next presentation from Madame Sophie Jacquel, Panorama of Brazil-France Collaboration.
Good morning, bonjour, bon dia. It's a great honor for me to be in front of you today at the FAPESP. As it was already been mentioned, it's a key partner for us in French-Brazilian cooperation in health. So I'm really happy to be here for this workshop, bringing together French and Brazilian researchers in the field of health sciences. We can see with the number of people present at the meeting that it really highlights the importance and the vitality of the scientific cooperation between our two countries in the crucial area of health. For many years, that it was mentioned already by Professor Zago and by the Consul, France and Brazil have forged strong and fruitful ties in scientific research, and our collaboration continues to strengthen and diversify, addressing the global challenges of our time. As the Consul mentioned, the inauguration of the research center recently in São Paulo really show, and the Institut Pasteur and the CNRS House really affirm our commitment on both sides to working together. So I will start maybe just with a broad presentation of who we are and what we do. I will go quickly, but I don't know if all of you know exactly what is the French Embassy and the Consulate doing here in Brazil, and what are all the French research organisms present in Brazil. And then I will focus a bit more on health cooperation. But before to start, I would really like to thank the Professor Zago, the Professor Castro, the Professor Menezes, and the Professor Neil Olsen and Leander Coley, without whom this workshop could never have taken place. And all of you for the participation. So here we go. Well, as you know, we had a presidential visit this year and a meeting between Emmanuel Macron and the President Lula. And this meeting gave birth to a new strategic roadmap, France-Brazil, from 2024. In this roadmap, we have a strong focus on health, and especially on the global health, One Health global approach. So it's it's our duty now to really enhance the cooperation in this area. I don't know if you know, but Brazil was nominated by the French Ministry of Research as one of the 12 country provider of science in the world, which means it's one of the 12 priority countries for France to do research with. So the nomination happened like last year, and it was already quite a strong signal of the importance of Brazil in our cooperation. We have in Brazil a vast network at the service of cooperation. We call my services at the French embassy. So we have the embassy in Brasilia and 4 antennas in Rio, São Paulo, Recife, and Belo Horizonte. We also have several research organizations, as you can see on the slide. The CNRS, of course, IRD, which is now my English, I know I don't speak English every day now. The Development Institute for Research for the Development, let's say that like that. We have INRAE, CIRAD, INRIA, and of course, Institut Pasteur de São Paulo. So you can see it's quite a strong presence of French research organization in Brazil. Within the service de coopération, just for you to know, I think you already know our team because you work with the team in a daily basis, but just to remind it, so we have a scientific counselor in Brasilia, we have a scientific counselor here in São Paulo, which is Nadège Mézier, present is today with us. And we have the attaché in Brasilia is really focused on health and innovation issues. So you have a strong link with, especially with São Paulo and Rio de Janeiro, but also with Belém and many other cities in Brazil. And then, of course, we have a university attaché, which is linked with Campus France. We help with the mobility of our students and our young researcher. What do we do at the embassy? So I will go quickly, but many of you maybe have already participated to our program. We try to enhance cooperation, scientific cooperation, reciprocal mobility for students, for doctorate, postdoctorate. We try also to incentivize regional and international cooperation projects, and also the vulgarization of science made by French and Brazilian researchers. We fund also research projects. We join programs like Amazonia +10, and all this program. And we have also academic chairs. So maybe some of you already participate to our academic chairs. And special projects related also between France and Brazil border in Guyane. So that's quite an important also specificity of our international cooperation. Well, that is all the bodies we are working with. I think you already know that. We also have scholarship programs, but I will go quickly on that because you can find all the information if you have any interest for your students to apply for scholarships in France. You can go on our website and find all the information to participate to those calls. Maybe I'll go quickly on that, sorry. So maybe now to focus more specifically on health. You've seen I had 3 slides about IRD, CIRAD, and CNRS in particular, because that's really the 3 main research organizations present here in Brazil. And those 3 organizations works on health issues at different levels and in different areas, but all of them develop health cooperation with Brazilian researchers, so that's why I highlight them a bit in the presentation. So why is Brazil a strategic partner for us? I think Professor Zago and the Consul already mentioned that, the importance of our cooperation in publication, especially. But I would just like to say that our 2 countries really face common challenges and share similar opportunities in the science and health research. We have a big topic on emerging infectious diseases, which is clearly a public health issue, and in which we have strong expertise on both hands, in France and in Brazil. And really, it's also, in Brazil, it's a cutting-edge research at Fiocruz, Butantan, and Evangro Chagras Institute, for example. France and Brazil have a long history of working together on this topic, on emerging infectious disease like hepatitis, tuberculosis, arboviruses, so yellow fever, etc. So that's really also a big priority of our cooperation and the work we are doing on health at the French embassy. Of course, we have climate change and deforestation, which represent additional risk for an emergence of new diseases. We've seen, and COVID is one of the examples, but we've seen in the past years, really the multiplication of human-animal interaction. And I think a strong collaboration between France and Brazil, it's more relevant now than ever on these topics. And the health crisis has highlighted that dramatically, but that really highlighted that. All these factors leads to the importance also of developing the One Health approach I mentioned earlier. We see with the loss of biodiversity, it is really important to develop this approach, and we are happy to share this approach with Brazil and with Brazilian researchers. Brazil is also, I have to say, a fantastic terrain for researcher. I'm sorry to put it that way, but considering its diversity, all the ecosystems, the different ecosystems, the biomes, the diversity in population, in climate, it's really the paradise of researcher, and especially on health also. You have a lot of very interesting data on health, and I think that's really important for us in a scientific point of view. And of course, I should have mentioned that on the first place. Brazil is it's also a strategic partner because of this scientific excellency, but that's without mentioning it. It was already said before my intervention. Up. So we have a strong cooperation and historic cooperation, and this cooperation is now renewed. I mentioned the presidential visit in March, which set priority really in global health. And the visit also have central focus on biodiversity, of course, but also on specific health relationship. One objective is really to strengthen the One Health approach and social determinants of health to reduce inequalities and achieve the sustainable goals, development goals that we share and that the President Lula is really attached to achieve. Both our countries are engaged in supporting the WHO. They really reaffirm the role of the WHO in global health, and it's also a common point on our cooperation. In order to prevent future pandemic, we set up 3 different priorities in our collaborations. Is really strengthening public health emergency response system, strengthening our exchange of information and epidemiological surveillance, also increase exchange and training programs, including the new WHO Academy in Lyon, and last but not least, also increase collaboration in research, development, and production of vaccine and medicine. So there's quite a big agenda for our researcher, but I'm sure we will manage to succeed in all of these points. Maybe also to mention, there is ongoing discussion with Brazil to join the initiative, the international initiative PRESOD. I don't know if all of you know this initiative, but it was launched in 2021 by France, and it now turned into a real international initiative, joining 25 countries and more than 200 institutions worldwide. So this international initiative aims at preventing outbreak of zoonotic pandemics while ensuring food security and means of subsistence for the population, more poorest communities. Because why this initiative? Because we face dramatic information that 75% of emerging disease in humans comes from animals, and we need international research to increase international research. And keep in mind this One Health approach in order to react more quickly next time we have a pandemic and try, of course, to avoid it if it's possible. So we really like Brazil to join the initiative. I think it will really help also to increase again our work on the topic. I was mentioned, so we have a very historical and structured cooperation based on Brazil's scientific excellencies. And the sharing, of course, I mentioned the cooperation with French Guiana, but the sharing of a border in Amazonia, it's really a key factor for us also in health cooperation. We face the same challenges, the same problems also, and we can really tackle those challenges together. I have to mention that the president announced the creation of a bilateral center for research center for biodiversity in Amazonia. So this center will normally be launched in September. And of course, one of the key topics of this center will be health research. So it will be one more opportunity, if we needed it, to work together on the subject. So I mentioned the CIRAD, the IRD and CNRS, and the Institut Pasteur de São Paulo. I think it's really important because it really structures the cooperation on health. We have a lot of other French institutions working on the topic, and we decided to make Brazil a priority for the cooperation, like INRIA, INRAE, l'Université de Lille, l'Université de Saclay, etc. So really many institutions. But those CIRAD, IRD, CNRS, and Pasteur are really structuring our cooperation in Brazil. And I have to mention also the recent creation of a platform of Pasteur in Fortaleza also, together with Fiocruz. So we already mentioned that. I just have to say that for Institut Pasteur, so we would like to thank again FAPESP, because it was key to achieving the implementation of Institut Pasteur, and to thank also Paola for her work on the Institut Pasteur. And we hope that the new platform in Fortaleza will follow the same path and have the same success. And we have there an international expert based in Fortaleza to help to make this project a reality in the future. I already mentioned the emerging infectious disease, so I think we're okay. And just to focus also on the role and the partnership between the ANRS, and the Evandro Chagas Institute in Belém, which was, of course, supported by the FAP and the National Confederation of FAPs, the CONFAP. There will be a big workshop taking place also in the autumn, so the French autumn, so here will be the summer, but like in November in Belém, really focusing on emerging infectious disease, and it shows that this topic is really important for our cooperation. Also, I would like to mention a joint program on accelerating technology transfer in collaboration with Fiocruz, public company, Biomanginos, and Farmanginos, which I think also it's an interesting part of our scientific collaboration, going into technology transfer in the economic part of the result of our scientific cooperation. So I already mentioned Guyane, and the fact to share a border is a key factor for us. At the embassy, we also try to really support the development of this cooperation between Fiocruz and ARS. So ARS is a regional agency for health in Guyane. The Pasteur Network also and Pasteur Institute in Guyane is involved, também the Amapa government. to really work on the health at the border issue, which has many different components, because it's research, but it's also monitoring, alert mechanism on the transmission of disease between the border, and also on access to health services, which is a huge challenge for population in this part of Brazil and in France. I won't mention all the cooperation you can see on the slide, but we are also a big partnership between Frocruz and École des Hautes Études en Santé Publique in France. And we really love to encourage new collaboration in various parts of Brazil and to work with the north, the northeast, the Guiana, the south of Brazil. And I would like to mention the initiative Amazonia +10, which I think is a really good example how we can all work together, all part of the Brazil and with international cooperation. And we're really happy to be part of this program. Another priority for us is to encourage collaboration on artificial intelligence and its application to health. I think Brazil is really, even more advanced, I would say, than France on this topic. It's really a very interesting approach on how to use AI and really apply in the daily work and in the health system, which is in the SUS system, but also in all the application to health. And I think we have a lot to learn about that, and it's a very interesting area for our cooperation. I will go quickly on the Institut Pasteur. Not that it's not important, because I think you already know, considering how many times we mention it, that it's really important, but because we'll have a presentation later, and I think you all know also a bit about it. But I would just like to enhance that's why it's so important, because it's really an achievement. There's only 3 other Pasteur Institutes in Latin America and the Caribbean. In Guadeloupe, in Guyane, which has French territories, and 1 in Montevideo. So it really shows the importance of Brazil within the Pasteur network. So you can all go and visit the Institut Pasteur if you want to, but it's really located in the USP campus, and it has impressive installation and laboratories, including level 3 laboratories. So it's really a good instrument for research and Franco-Brazilian research. So you can see here, I put quickly the main research groups that are the interest of the Institut Pasteur of São Paulo. You can see it's integrative biology, eco-immunology, modeling diseases, vaccinology, all these diseases as really the focus research group of the Institute. And concerning the platform in Fortaleza, and you can see the slide is still in French, but it's okay. You can see that the main topics are really immunology and immunotherapy. So also very interesting topics for our cooperation. I will say a few words about innovation issue, which are linked to health, but not only. And we are really keen to promote, I would say exchange, because promote French model of innovation and technology transfer is interesting, but also the technology transfer, Brazilian technology transfer, especially in health and on the vaccine, is really interesting in Brazil too. So that's one also of our main objective concerning innovation. We like also to promote the exchange of experts and sharing of experience on innovation issues, and to promote the fast track intellectual protection modalities between the French INPI and the Brazilian INPI. That's really, it could be seen like an anecdote, but it could really help technology transfer and businesses to really invest in innovation on health or other topics. So it's really something we would like to implement briefly. I think I've already talked enough, so I will just finish with some final words. As I said, I'm really happy to be here. I'm sure the 2 days of discussion, of exchange and presentation really allow us to exchange knowledge and perspective and create new research projects. I believe in that. So let's all go to work on that. And you can always count on the support of the French Embassy in Brazil, as well as the French Consulate in São Paulo, to support you, to help you in creating those collaboration and those projects, if you need to. If you don't need to, it's okay, we're happy also. But we're really here for you, so don't hesitate to knock on our door if needed. Thank you very much. I wish you a nice 2 days of workshop.
Thank you, Sophie. I would propose now we have a break, a coffee break at second floor, 30 minutes, and then we come back here. Thank you.
this session about CNRS and our initiatives involving FAPESP, USP, other research institutions in São Paulo, and CNRS, I would invite Livio Nico from CNRS, the regional director of CNRS here in South America, Nicolas Rito, chercheur de CNRS, based in, well, you listen to him, but based in Ribeirão Preto, this international research laboratory we have in partnership with the USP CNRS, and José Carlos Alves Filho, the coordinator of this initiative of the International Research Laboratory. Please take a seat. Just my welcome to you all. I will immediately give the floor to Livio, and further on we can discuss more details or question and answer session about this really extraordinary initiative that we call the International Research Center of CNRS in São Paulo.
Obrigado, Fernando. Hello, everybody. First of all, I would like to thank the organizers for having invited me here and continue to explain what are our international collaboration tools in CNRS, because I think and I feel that each and every new presentation about these tools is very necessary, as everybody still continue to ask me what is a project, what is a laboratory, what is the center, and so on and so forth. So before starting, I just would like to know who are the French people in the room. Do you speak Portuguese? No? Okay, so let's go in English. There was a trial, because I think that I have to push my discourse, my speech in Portuguese also, as the information is very, very important. But anyway, I'm going to do it in English. So I'm going to explain you what we are doing here with this International Research Center that we called Transitions, in between the CNRS, which is the National Scientific Research Center in France, and the University of São Paulo. And I don't have the possibility to, yeah, okay, it's there. My plan is this one. First of all, I'm gonna tell you a few words about the CNRS office in South America. What are our missions? What is the team? You're gonna see that it's a huge team working on South America. We are two. A few key figures about the CNRS, the organization, international relations, the partnership in between CNRS and USP, what motivated us to set up the International Research Center, and a few words about the architecture of this center, and of course, several words about the upcoming events in this frame. Okay, so this is the team. My name is Livio Nico. I am the director of the office, and I have one collaborator. It's Pascal Saint-Gé. We are based actually in Rio de Janeiro at the General Consulate of France, in the center, the Centro, de Rio de Janeiro. And we are still there until next August, 1 month, because in about 1 month from now, we are going to move. I will let you switch. We are going to move in São Paulo. After 14 years in Rio de Janeiro, not because the city is not cidade maravilhosa and tudo mais, but because now things are happening here in São Paulo in terms of strong collaboration with the University of São Paulo. Of course, we are continuing to cover the South America territory, and we are not doing this alone. Please, next slide. We are doing this with people in Paris, actually, our colleagues, Antonia Alcaraz Pardo, who is South America Program Manager, and Jean Tev, who is Deputy Director for the Americas. Until September, he will also move in Strasbourg for other missions. So we're gonna have a new colleague working for the Americas at the CNRS Europe International Direction. Our missions are here. We are working on representing, consolidating, and prospecting on all the South America continent, again, not the Latin America. We are leaving the Mexico for our colleagues from Washington. But we are working on these 3 missions, representing the CNRS brand and what we are doing in terms of collaborations with our partners in Argentina, Chile, Brazil, wherever we are. Consolidating our actions is advising our colleagues from CNRS how to reach the upper level of their collaborations, going from an emerging action to a research project to a research laboratory and so on and so forth. I'm going to explain you in a few slides what are those tools. And we are also prospecting. It's sort of sentinel role, feeling the trends in collaboration with our embassies and consulates here in South America and with our institutes at CNRS in Paris. So this is CNRS. I would say, I would like to focus on what CNRS isn't. So CNRS isn't a founding agency. CNRS isn't FAPESP. CNRS isn't CNPq. But CNRS is an organism of research with 32,000 employees, among them 28,000 scientists, researchers, administrative technicians, 4 billion euros in 2024. Let's see what happens next year. Private joke. With 1,000 laboratories in France, more than 1,000, 10 scientific divisions. I'm going to get back on that in a few minutes. Something which are very proud of is are our 240 joint research structures with companies, sort of common labs with companies. 2/3 of our publications are signed with a foreign colleague or foreign laboratories, universities. And 94% of our publications are in open access. It's something which is, okay, you can forget this after, but it's very important. Our scientific divisions at CNRS are these ones. So we are divisions working on mathematics, information sciences, engineering, chemistry, physics, but also particles, earth and universe, ecology, environment, biology, and also human sciences, which is very important. Each of these divisions are taking care of their laboratories in France and abroad. I told you that we are a booster for innovation. This is something which are making us really proud, because we have these common labs with companies. Some of them are here, the major ones, Airbus, Thales, Michelin. But there are a lot of them which are hidden and which are setting up common labs with our researchers in France, but also abroad. On one slide, I put the international cooperation tools of CNRS. So let's go again. We have actions from the exploring level through the consolidating, structuring, and integrating. It's like a video game. If you win the first level, you get on the upper one. If you win the second one, you get on the third one, and so forth. So an action, an emerging action, you have 2 PIs, one from Brazil, one from France. They don't know each other, but they would like to work together. So what we are doing is helping them know each other during 2 years, funding trips from one side to the other of the Atlantic, and let them know each other. If things are matching well, we are going to the next level, which is either an international network or an international project. The difference in between is the number of countries which are involved. A project is 2 countries, France and another one. A network is at least 3 countries, France and 2 other ones. These are projects for 5 years, And if things are going well, we are going to the upper level of the video game, which is the International Research Lab. And in this case, what we are doing is creating a real lab with our partner abroad, with people coming from France for long stays, at least 6 months, staying there with the direction team, with administrative staff when it happens, and so on and so forth. So it's 5 years of common work together physically and not virtually in the place where we are setting up the lab. And if things are going well, and if we are noting that with one university in the world, we have a lot of structures like that already existing, labs, projects, actions, we are deciding to set up an international research center. So the difference in between a center and the other ones is that the other ones are monodisciplinary and the center is pluridisciplinary. Okay? The orange circles are the international labs in the zones, in the areas that you see there. So as you can see, we have several international labs in South America, some of them in North America, and so on and so forth. And you have also the locations of our representations all over the world, 10 of them: Ottawa, Brussels, Washington, Rio de Janeiro, until August. And then after August, it will be in São Paulo, Pretoria, Melbourne, Singapore, and the other ones. We have more than 70 international research labs in the world, and 4 of them are with companies. For instance, with Thales, we have an international lab in Singapore, with Saint-Gobain and Solvay in the United States, and with Naval Group in Australia. It was before the story of the submarines. And, okay, we stayed there. These are our international research centers. We have 5 of them. We started to set up international research centers since 2021. The first one was with University of Arizona. We called it France-Arizona Institute for Grand Global Challenges, and you can see all the disciplines that are covered, from natural, social and digital environment. We have an international lab there, and okay, so it's a real, a very important international research center because it's the first one, and the dynamic is really well established. The second one is with Imperial College in London, and the areas are there: mathematics, engineering, artificial intelligence. The third one is University of Tokyo, with the disciplines which are there. The fourth one is University of Chicago, on particle physics, humanities, and astronomy. And the fifth one is with the University of São Paulo. So on this slide, for our French colleagues, why University of São Paulo? Is because that University of São Paulo is huge. It's the best one in Latin America. 8 campuses. Some of them are really disciplinary. For instance, in Piracicaba is the agronomy. In São Carlos are the hard sciences. In Ribeirão Preto is the medicine, and so on and so forth. A lot of students, 100,000, very good students, docents, and all the other data are there. But the most important thing here is what is on the right side of my slide, is the level of investment of the state of São Paulo in science and technology in 2020. This is from your Pesquisa journal here in FAPESP. I would like to congratulate it because it's a very nice journal. And as you can see, São Paulo was investing in 2020 almost 10 billion reais, which is more or less 2 billion euros. And the second state is Paraná, with 8 times less investment than São Paulo. The third one is Rio de Janeiro, and so on and so forth. So São Paulo is hugely investing in science and technology, and we hope that it's going to continue. So this is for São Paulo, for the USP and the state of São Paulo. These are data on our publications with USP, CNRS and USP, last 5 years. And I was thinking about how things are matching with what President Zago already shown, I think that our sources are different, but anyway, the numbers are here. These are the disciplines where we co-published with our colleagues from USP in particle physics, astronomy, ecology, environment, and so on and so forth. These are the international cooperation tools of CNRS with colleagues from USP. As you can see, we have 8 international research projects and networks in various disciplines: engineering, biological sciences, earth sciences and astronomy, biology again. 3 of them are on human sciences, which is a very important partnership in between France, all over France, and the University of São Paulo in human sciences, and also an international network on marine biology. And we have one international lab that already started in 2024. We have Professor José Filho and Nicolas Rito, which are the directors of this lab, and they will show you what they are doing there and intend to do in the next years. And the second lab, international lab, that will be set up in September this year on human sciences. So 2 international labs. Okay, so I have a brief history of how this International Research Center with USP started. I'm going to do it fast. First of all, Rector of University of São Paulo, Professor Carlocci, wrote a letter of intention to our president, Antoine Petit of CNRS, in December 2022, telling, okay, we have a lot of collaboration, let's do an international center. So a few days after, our president answered that everything is okay, we're gonna do it. In March, we had a visit last year of our president here in São Paulo, and they signed, Professor Carlocci and Antoine Petit, a letter of intention to create the center without knowing very well what will be the disciplinary architecture. And we worked a lot with our colleagues from USP and from FAPESP on this disciplinary architecture. And I would like to take the opportunity to thank Fernando for his help on this. And okay, then we started working on workshops, thematic workshops, in order to see how things are going, if we can do something, for instance, in informatics, if we can do something in science, human sciences. We had a workshop also, so this is your International Research Lab that started in December. We had a workshop on ecology and environment this last March. And we also participated to the PROASA program launch here in FAPESP, which is a program of research on South Atlantic and Antarctica. So a lot of workshops. This is the magic word. Let's do workshops and let's see if things are going well. It's exactly what we are doing here these days. And we finally decided that the architecture of the International Center in between CNRS and USP would be something like this bridge, which is the Viaduc de Millau, for people that are knowing it, which has exactly 7 pillars, if you are counting them. And it happened that we also decided to have 7 disciplinary pillars in our center. The first one is human and social sciences, because of the projects, because of the partnership. Information sciences, environmental sciences. The 4th one is quantum technologies, then biological sciences, agro and decarbonation, and the last one, but not the least one, oceans, oceanography. And we decided that this would be the bridge in between CNRS and USP in terms of International Research Center, okay? Luckily, because if we had to choose the Niterói bridge with 453 pillars, I wouldn't be here today to do my presentation in less than 1 hour. So each of these pillars has responsibles, persons which are in charge with, making them living, consolidating. Some of them are mature. I'm speaking about the pillars, not about the pilots. Some of them are advanced, others are really starting, and that is why we are still at this stage, okay? The bridge is not ready. We are working on it. The center has been created in October 2023, less than 1 year ago, and we are continuing to build the bridge. But in last March, actually, we had our president that came again here in São Paulo, and some agreements had been signed, and one of them is very important, is the creation of what we are calling Maison du CNRS, CNRS house. And this is not religion, right? It's not Maison de Dieu. It's Maison du CNRS. It was actually the suggestion of our Professor Carlotti, rector of University of São Paulo, and we found it very nice as name. And so our president signed this agreement to move the CNRS office from Rio to São Paulo in this Maison du CNRS, and to integrate the CNRS presentation with the International Research Center, and everything will take place there. There was also an agreement that has been signed in between CNRS, FAPESP, and USP, where a budget has been decided to support the actions which are taking place within the area of the International Research Center, with, for instance, a welcome package for French scientists that are coming here and are settling here in one of our international research labs, and the possibility to register at USP and to have the opportunity to apply for auxílio regular, projeto temático, and so on and so forth. Now the future actions are here. We have other workshops that are to come. One on human sciences, and this will be the inauguration of our international lab, Monde en Transition. 2 workshops in France in October, one on ecology environment, another one on informatics. There is a workshop in Ribeirão Preto in November with the presence of our director of the CNRS biology there. We have another one which is going to be online on quantum tech. And we have a high-level meeting in Paris in between the rector of University of São Paulo and his team, and the president of CNRS and his team on 9 and 10 of January in order to assess the activity of the first year of the IRC and the vision for the next 3 years. And I will finish my presentation with some photos, which are really heavy, and so we are going to move here. For those that are knowing, this has been Banco do Brasil, next to the Reitoria of University of São Paulo. And from now, this is called Maison du CNRS. And inside we have open spaces in order to host our researchers and their partners. We have a space for events, 70 places where scientific presentation can take place, and events, of course. We already had some events. This is Human Sciences workshop last year in September. These are people from the ecology environment pillar with the workshop in March, and the agreement that has been signed with the personalities. And this is the way in which we put the brand Maison du CNRS on this space. And of course, other pictures showing the fact that we can now work in São Paulo at the Maison du CNRS, next to the Reitoria, next to the Institute Pasteur. And we are here for you, starting with next August. Thank you very much.
Good morning to everybody. I'm Nicolas Rito. I'm really pleased to be here. It's my first time here at the headquarters of FAPESP, It's a beautiful building, and I really would like to take the opportunity to thank all the people involved. What I'm going to present today that has been introduced by Livio, the creation of our International Research Laboratory. And also I would like to thank Zeka for hosting me in Ribeirão Preto, and Livio and Nadej for all the support. It's been only 5 months, but we are really, I think, in a really good dynamic, and I'm really happy to share you what we are and what we intend to do in the next couple of years. So, I'm going to try to point some. So the IRL, so International Research Laboratory, has 2 affiliations, the CNRS and the University of São Paulo, and they joined to create our unit. It's the IRL 2029, that's the French number. We call it IMEA in short. It's Regulation of Host Responses and Human Health. And so we are only 2 people at the moment in the lab. Zeka, who is the director, and I'm the deputy director. And so it's been created as of January 1st of this year, and it's for 5 years, and then it's going to be renewed for more 5 years upon HCRS evaluation, like any other lab in France. So this was already introduced by Livio, but I just would like to say that there are 5 ERLs in Latin America. You can correct me if it's wrong. One is in Brazil, in Rio de Janeiro, on mathematics, and we are here located in. I don't think I can point. Okay. So in Ribeirão Preto, and it's the first one in biological sciences in Latin America, and it's the second in the world. The first one is in Singapore, and there are less than 10 research center. You mentioned 5, but I think there are a couple of them. Like in Kenya, I think, no, Tanzania? No? Okay. So at the moment there are 5 of them, and one is in São Paulo state. And so as you said, the agreement has been signed, the letter of intention last year, and now it's been signed officially this spring. And so I put this map for, especially for French people, just to have a little perspective. So France is like 15 times less big than Brazil, and just the state of Minas Gerais is bigger than the whole France. So just to give you an idea of how big is the country. So we are located in Ribeirão Preto, the IRL, which is, according to Brazilian standard, really, really close to São Paulo. It's like 300 kilometers next by, like really close. But really, it's not that far, and it's also not really far from Rio. It's like doable by car. And so that's the satellite view of Ribeirão Preto. It's not so big as compared to São Paulo. It's like 700,000 people. And the campus actually is really, really nice. So it's here on the west part of the city. It's used to be a big coffee plant for many, many years. And then it was given to the city or to the state if it was to be dedicated to science and education. So they created the hospital, the first faculty of medicine outside of a state capital. And so the whole campus, it's 600 hectares. So it's like, it's 586. It's 600 times the Stade de France in terms of size. So it's also a really, really big campus. And it's a beautiful one. Marion has been there, and she can say, maybe it's confirm, it's a really beautiful campus. A lot of trees. It's really enjoyable. Just to point here, so we have the HC, so the General Hospital of Ribeirão Preto. And we are just located below in the Faculty of Medicine from Ribeirão Preto, FMRP in short. That's where the IRL is located at the moment. And so that's like a view from drone. So that's we're here in the trees. And that's the front view of the building, which is an historical building from the patrimony. Okay. So our IRL is in the field of immunology, and the administrative management is in Paris. So we get a lot of support from them, but everything is in Paris. And our budget is on the CNRS, like recurrent money every year. And we also are really grateful to have the support from the FAPESP, so where we can apply for fellowships and grants. And the good thing is that we can also apply to grants in France. If you are affiliated to the IRL, then you are a member of the CNRS database, RESEDA, and so you can also apply on your own name as a PI or as a collaborator for French grants and also for some of the European grants, not all of them. Okay, and so what I'm going to talk today is about what we are doing at the moment. So it's based on our previous collaborations and interests, and the topic is on the immunoregulatory function of the protein STING. And my background is more on the lung, and at least for this specific subject, and for Zika is on the psoriasis. Okay, and I also I come from a lab in France, in Orléans, called the INEM. So also part of this work has been done, or most of this work has been done in Orléans. So just to acknowledge them. Okay, so a bit of now science. So the STING protein is an innate immune receptor. It's located in the endoplasmic reticulum membrane. I'm sorry, I would like to point, but I cannot do it. So just and so it's been discovered in 2008. And then there has been a lot of work trying to elucidate the pathway. But basically, when you have a situation like upon infection, when you have nucleic acids and specifically DNA in the cytoplasm, then you have this enzyme called cGAS that is going to use GTP and ATP to form a cyclic dinucleotide called cGAMP. And this is the ligand of the innate receptor STING. You can also have bacteria producing their own cyclic dinucleotides, which can act directly as a ligand for STING. And downstream of STING, you have different pathways. I'm going to come back to that, but the main one is type 1 interferon. Okay, and in our case, we are more interested not in the context of infection, but in the context of steroid inflammation or any kind of tissue damage, where you have the cell death and the release of self-DNA that can bind to cGAS or any other DNA sensor, and then inducing STING expression. So STING, it's been shown to be really important in the context of viral and bacterial infection. It's also, it has been described a role in many, many different situations. Whenever you have tissue damage and cell death, you can have a role for STING. And in inflammatory conditions, the outcome of STING activation is very diverse. So it depends on the tissue, on the environment, and so on. In cancer, also it has ambivalent function. And the general dogma is that the acute STING activation is protective through type 1 interferon-mediated anti-tumor activity. But then if you have chronic STING activation, you can have more interferon-induced tolerance, and on the opposite, more tumorigenesis. And also, just to mention, there is a disease, a really rare disease that is due to a mutation in the gene, in the STING gene. And this is a gain-of-function mutation, and the disease is called SAVI, for STING-associated vasculopathy with onset in infancy. So in that case, you have a constitutive STING activation, and it's considered as an interferonopathy. Okay, but in my case, I'm interested in the lung, and especially in idiopathic pulmonary fibrosis, which is the most common and severe form of ILD for interstitial lung disease. It affects about 1 million people worldwide, and the average age of diagnosis is pretty late, about 65 years of age. And there is a very low survival post-diagnosis, and the current treatments display very poor efficacy. So there are no clearly established causes of the disease. It's based on recurrent microinjuries of the alveolar epithelium, leading to a dysregulated wound healing processes, excessive digestive deposition, and this leads to a decreased lung function. It's really associated with a lot of different comorbidities. So just to go very quickly, that's a lung architecture where you have alveoli that are really important for breathing, and the alveoli are lined up with epithelial cells and with immune cells such as macrophages and other cells. In the context of fibrosis, you have really massive cell death processes, a loss of ROS, oxygen species, and also the migration, the proliferation, and of fibroblasts, And this is really leading to tissue scarring and almost no alveoli left, and that's why you have really difficulty to breathe. So although it's a rare disease, there has been more than 500 clinical trials so far, and research is still really important because although there are some drugs that are on the market, they are really not that efficient, only in some cases, and it's only to delay the progression of the disease. It's not really to treat the patients. So in mice, I do think the most canonical model is through bleomycin, which is a DNA intercalent. It creates DNA stain break and cell death, leading really, really quickly to inflammation, neutrophilic inflammation, leading to collagen deposition, myofibroblast migration, and fibrosis. So my focus has been on host-derived dangerous signals involved in the inflammatory and fibrotic process. Over the years, I worked on ATP, uric acid, and other molecules, and now I'm really interested in self-nucleic acids, so the STING pathway. Okay, so what we do in our lab, we administer bleomycin intranasally, and then we can look at different time points to see the immune response and the tissue damage. And usually by 2 weeks, you already have a strong lung fibrosis with, for instance, lymphocyte accumulation. So what we have published a couple of years ago is that on the opposite to our hypothesis, we showed that STING is actually important to control the pathology. When we compared wild-type mice treated with bleomycin to STING knockout animals, we showed that the STING-deficient animals have increased tissue fibrosis with increased body weight loss and associated with a lot of other markers associated to disease, like here, fibrotin 1 expression. And importantly, this was type 1 interferon independent. So I showed you that the canonical pathway downstream of STING is type 1 interferon. And here our results suggest that STING is important to control the pathology, but it's not through a type 1 interferon. So we are now trying to investigate the mechanisms behind it. And also to try to characterize which cells subset are really important for the disease. So this is mainly the work of Dorian, a PhD student in my lab in Orléans, who just happened to be here in Ribeirão Preto for 6 weeks. So also he was the first French PhD student to come to Brazil to actually perform experiments. We had a lot of exchange, but people from France would come for conference, to give talks, but he was the first one to really do experiments. So I'm really happy with that, and he's going to be, I hope, the first of many people. So what he used is a STING reporter mouse strain. So it's called the OST mouse strain for one strep tag. And basically what's been done is an addition of a tag, like a biotin tag to the STING protein. And then we use a streptavidin-like molecule that is coupled to a fluorophore to then be able to track STING expression by flow cytometry or by immunofluorescence. And whenever you have increased fluorescence, it means that you have STING expressed, not the activity of STING, just the expression. So we treated these mice with bleomycin, and we look in all the different cell subsets in the lungs. And as you can see here, we do have a strong expression of STING in the lymphocytes, both CD4 and CD8s, as well as the B cells and NK cells, but there was no difference in terms of expression upon treatment with bleomycin. Comparing the white and the blue histogram, there is no difference in terms of expression. We saw really low expression of STING in neutrophils, and we have some expression, kind of strong expression in eosinophils, and at the moment we have no clue what this is, but it can be the matter of following project. But what we saw is an increase in other myeloid subsets, included alveolar macrophages, interstitial macrophages, and DC subsets. Upon bleomycin, you have increased expression of STING in these cell subsets. We performed a single-cell RNA-seq on sorted lung macrophages. This is still ongoing, but I just wanted to show you this result. On the left, what you have is these myeloid populations from naive mouse, and in purple is the STING expression. So we have a lot of STING expression in alveolar macrophages and interstitial macrophages, and then upon bleomycin we have the diminution of alveolar macrophages population, which is known, and then we have a strong STING expression in interstitial macrophages that can come from monocytes, the blue subset, and also in disease. So that confirms what we have seen using our mouse strain, and we now want to explore more in deeper what these cells are actually doing. Okay, so now the mechanism. So we know that it's not type 1 interferon dependent. We also excluded type 3 interferons, the role of TGF-beta, and we are really now exploring the autophagy pathway downstream of STING expression. So just in this illustration, upon STING activation, you have transcription factors, NF-kappa B and IRF3 that are activated, canonical for type 1 interferon, IL-6, TNF-alpha, and other genes. It's been described also in certain conditions that STING activation can lead to cell death through lysosomal instability. So this is lysosomal dependent cell death. And in the middle, you have autophagy that is promoted by STING activation. So there are a lot of papers trying to understand the molecular pathways. But for instance, one paper showed that LC3 protein, which is an actually really important mediator of autophagy, can directly bind to STING, and this facilitates the flux of autophagy. So this is really relevant in the context of our disease model, or the disease that we are studying, IPF. There are a couple of papers showing that really the autophagy inhibition increases myofibroblast differentiation. If you use mouse that are deficient for autophagy markers, then you have increased disability, and so on. So what we have done first, we tried to induce autophagy through a drug called carbamazepine. And what we showed is that this leads to a strong reduction in the immune cells recruited to both the alveolar environment and the lungs, as well as a reversement of the IL-10 production in the lung. And by histology, so promoting the autophagy was able to partially reduce the fibrosis. As you can see on the tissue sections, and quantified on the bottom left in the canonical score, the Ashcott score, and also in terms of collagen deposition, which is a hallmark of fibrosis process. So now more specifically, we also looked by immunofluorescence in the tissue sections of mice treated with bleomycin, and we do see a strong activation of autophagy. Here it's on myeloid cells. You have LT3, B1 and B2, and the marker of active autophagy is LC3 B2, which form like puncta, which means like active autophagosome. And when we compared B6 mice with STING knockout animals, we saw that there is a lot less autophagy in STING deficient animals treated with bleomycin as compared to the B6 mice. We confirmed these results by Western blot. So we can see also both forms of LC3 B1 and 2. So looking at the bottom fragment, we see that there is a difference, significant decrease in STING knockout animals as compared to the B6 mice. So clearly there is less autophagy in STING knockout animals, and we are now doing experiments to see whether this can explain why we see more fibrosis in the absence of STING. Okay, so that's the first axis that we are focusing on, and the second one is in the context of psoriasis. And this was done through a collaboration that Zeka and I did. So we had the chance to have a one-year PhD student from Zeka coming to our lab in France through an FL fellowship. So psoriasis is a chronic inflammatory skin disease. It affects about 3% of the worldwide population, so really, really frequent. It has a high economical burden associated with poor quality of life, and it's usually treated with steroids or corticosteroids. So the pathophysiology is well described. It's based on activation and proliferation of keratinocytes, and it's really a T-cell mediated disease. But the underlying mechanisms are still not fully understood. And this, as I mentioned, was done in part through Gymnab. And she took advantage of public data sets in collaboration with other people in Zeka's lab, colleague. And they saw that clearly the cytosolic sensors of DNA molecules are really, the signature is really increased in patients as compared to the controls. And then they did immunofluorescence images on human samples from patients that have psoriasis. So what they did, they took non-lesioned area of the skin and compared with lesioned area of the skin, and they really see a beautiful increase in STING expression shown in purple. So you can see that you have many recruited cells, you have lymphocytes, DCs, Langerhans cells, and others that are really expressing STING. So if we go close-up magnification, it's not all of them, so it's really interesting, but the cells that are expressing STING are really expressing a lot of them. So then she explored the relevance of these findings in using an in vivo model through imiquimod topical administration on wild-type or STING knockout animals. And what she saw is that the STING knockout animals, they have increased scaling, increased erythema, so basically increased pathology as compared to the wild-type mice. So that's a second example. It's not the, it's, you have many papers showing that STING, when you remove STING, you have less inflammation, less pathology. But in our case, in both in the context of lung fibrosis or psoriasis, we have the opposite. So that's why we are studying this immunoregulatory function of STING. So increased pathology, you can see it also here by histology. It's really clear. You have an epidermidis thickening and cell infiltration in STING knockout animals. And so this is quantified here with an increased number of lymphocytes, of neutrophils, and also of really important immune mediators like IL-17, IL-6, and IL-23. And also together with a decreased expression of type 1 interferon, which is expected because one of the main inducer of type 1 interferon here is STING, but also a really strong reduction of IL-10. So that's really interesting to us, and especially for Zeka, because his lab is really dedicated to understand the differentiation and functions of Th17 cells and IL-10 producing cells. But here, Timna is also exploring the mechanism. And what she has done first is try to see whether this white type 1 interferon mediated. So she used wild-type mice, STING knockout animals, and type 1 interferon receptor animals. And here also you can see that we don't phenocopy the phenotype. So using type 1 interferon receptor knockout animals, there is less pathology. So the protection that is mediated through STING is not by type 1 interferon. Then she wanted to see whether lymphocytes are actually important or not. So for that, she used mice that are STING knockout, but also RAG2 knockout, so they don't have any major B or T cells. And induced psoriasis through imiquimod administration on these mice. So that's again the increased pathology in the STING knockout animals as compared to the wild types. And then the STING RAG knockout animals, they reversed the phenotype. So showing that, indicating that lymphocytes are really important to participate in the exacerbation of the disease mediated through STING. So you have images of the skin and then a quantification on the right. And when you look at the same markers that I've shown you before, so we have now in the STING knockout, RAG2 knockout animals, we are almost back to what we have in the wild types in terms of IL-17, 23, IL-6, and IL-10. And as I mentioned earlier, it's really, for Zeka, it's really interesting because they have already studies going on and a publication on that. Like this one, when they show on in vitro CD4 T cells, that when you activate T cell with STING, you have reduced IL-17 production and increased IL-10. So then she wanted to see whether IL-17 is important. So she treated the mice with antibodies against IL-17. And so that's the control. The wild-type mice treated with is a chip control. And this is expected, this is known in the literature. When you remove IL-17 from the wild-type mice, then you have much less psoriasis. Again, in the STING knockout animals, treated with the chip control, we have increased pathology. But now when we treat these knockout animals with anti-IL-17, we come back to the wild types. So suggesting that STING is controlling IL-17 production, and this participates to the increased pathology. And also really interestingly, we see that when we use anti-IL-17 antibody, we don't have this increase in IL-23 production, and on the contrary, we improve the IL-10 production. So that goes in the same direction. Okay, so that's still work in progress. And to conclude, we show that STING exhibits protective functions in both IPF, mouse model, let's say, to IPF and psoriasis. In IPF, STING role is appears to be mainly in macrophages or disease subsets, and we are pursuing the role of autophagy. In this context, in psoriasis, it seems to be a completely different mechanism where it's STING activation within lymphocytes that can drive the protective or antipathogenic functions. And this is really important because there are a lot of literature trying to push to see what the use of STING agonists might do. But we have to be careful because also if we treat humans with these drugs, we might have also side effects that we are not so far really considered. And with that, I would like to thank you for your attention. And sorry. And obviously, the most important slide to acknowledge the people in my lab in France, especially Isabelle, Dorian, we did the work on IPF, and on the right is Zeka again, Chimina, and Kelly, who has also been to France and participated in this project. Thank you again.
So, good morning, everyone. Thank you very much, first of all, for the invitation and the opportunity to show a little bit about our international research laboratory that was just created. But I am also professor in the University of São Paulo, in Ribeirão Preto Medical School, and also I am part of the Center for Research in Inflammatory Disease, one of the CPITs from FAPESP. And I will switch a little bit to the topic, and then I will concentrate a little bit in my research line of investigation that's mainly understand the role of regulatory T cells. So just an overview about the interest of our lab in research. So we have a focus in understand the molecular basis of immune cell activation, function, and plasticity. Specifically, we are interested in these two groups of cells, regulatory T cells and M2 macrophages. On the other hand, M1 macrophages and Th17 cells. Why? Because these are important cells. For example, this group of cells is important for the regulation of the immune response. On the other hand, these two groups of cells are important for the induction of inflammation. And then we apply the biology of these cells in the context of infection, autoimmune diseases, and more recently in cancer. And these are the major publications from my lab. Just a general overview about Tregs. Tregs are CD4 T cells that are differentiated in the context of TGF-beta, and we have other CD4 T cells that are also differentiated after antigen presentation, and in the presence of different cytokines, they acquire a specific phenotype. So, for instance, in the presence of L12, CD4 T cells can differentiate into Th1 cells. That's important for the immunity against intracellular pathogens. In the presence of CD4, this CD4 T cells can be differentiated in the context of Th2. That's important for parasites. And in the context of L6 and TGF-beta, they are differentiated into Th17 cells that was already mentioned here, and then they are important for extracellular pathogens. Both Th1 and Th17 are also very important for the induction of inflammatory disease, chronic inflammatory disease, and also especially autoimmune diseases. And regulatory T cells are cells that are able to suppress these cells, to control, to maintain the immune tolerance, and to promote immunosuppression. And how regulatory T cells, they do that suppression. So they are very specialized cells that are able to express different proteins, surface proteins, for example, CTLA4. That's important for the to induce suppression of effector cells by cell-to-cell contact. They also are able to release some inflammatory, some suppressive cytokines like TGF-beta and IL-10. They also able to release some molecules that's important for the induction of apoptosis in effector cells. And also another group of molecules that are able to be released by regulatory T cells, including adenosine, that's important to suppress the effector cells. So these cells, regulatory cells, they are very important for the homeostasis of the immune system, but also they are important for the prevention of autoimmune disease, allergy, hypersensitivity of the immune system. On the other hand, they have detrimental role if we have overactivation of these cells, because they are important to suppress the immune response against tumor or the immune response against tumor. The master regulator of the transcription factor that regulates the differentiation of regulatory T cells is FOXP3. And mice or even patients that have a mutation in the FOXP3, they develop a lymphoproliferative fatal disease. We can see here in these mice, they are called scurfy mice. So they say if we have a deficiency of FOXP3, we don't have a differentiation of regulatory T cells. And these mice acquire systemic inflammation and they die in between 3 or 4 weeks old. Another important point of T cells is the plasticity. So unfortunately, or I don't know, in the evolution, what we have is that CD4 T cells, they are not terminally compromised or committed with the phenotype that they acquired. So, so naive T cells in the presence of L6 and TGF-beta in the microenvironment, in the inflammatory context, they acquire the Th17 phenotype. But after that, if they migrate into the site of inflammation, they, in the presence of other cytokines, they can acquire different other phenotypes. However, regulatory T cells, they are quite stable. So after differentiation of into the regulatory T cells, especially thymic regulatory T cells, they are quite stable. This is one published, one article published in PNAS by a group from California, that they did a very well characterization of regulatory T cells in the infiltration of the CNS. Sorry. So this is a model of experimental autoimmune encephalomyelitis, where they induced this by immunization of these mice with a myelin peptide, and they did this in these transgenic mice where they were reported for FOXP3 and they were also reported for IL-17 to track the infiltration of Th17 and the regulatory T cells into the inflammatory site. And one of the important sites of inflammation in this model is the spinal cord. And we can see that when it starts the symptoms in the beginning, we have a lot of Th17 cells infiltrating the spinal cord, especially in this portion of lumbar and thoracic lumbar portion. And when the disease is established, we have later on the infiltration of the regulatory T cells. Okay, and the regulatory T cells, they infiltrate into the inflammatory site, and despite we have a lot of pro-inflammatory cytokines there, they stay stable. So this is the course of this. So we have the pathology. In the beginning, we have the Th17 infiltration. Later on, we have regulatory T cells that induce the remission of the disease. But the question is, how regulatory T cells can maintain the stability in a very hostile microenvironment. So in the presence of pro-inflammatory cytokines, we know that this can induce the plasticity of the T cells, but we know that regulatory T cells are relatively stable. So we were interested in understand a little bit about that. And then we started to investigate a few years ago the role of adenosine and its receptor in the context of the immune regulation. So adenosine is a nucleoside intracellularly important for ATP generation, and in the extracellular compartment, ATP can be hydrolyzed into adenosine and then activate four different receptors. Specifically for the immune system, one of the important receptors is the adenosine receptor A2A, and this is a GPCR that induces the activation of adenylate cyclase and then the production of cyclo-MP. This pathway leads to activation of CRAB, that's important for the production of IL-10 and the inhibition of NF-kappa beta. In an important collaborative way with a group from France, where originally Nicolas belongs, we published this paper a few years ago showing the importance of adenosine metabolism by a subtype of B cells important to induce the suppression of macrophages. And then when we think about adenosine, so adenosine is produced by these plasmablasts and then activates A2A receptor in macrophages. In terms of T cells, it's well known, well described that A2A receptor is also expressed in effector T cells, and this is one of the tools that regulatory T cells use to induce the suppression of effector cells. However, we know that regulatory T cells also express this receptor, A2A, but it's not so clear the function of this receptor in regulatory T cells. So we explored this receptor, trying to understand what's the biology of this receptor for the stability and function of regulatory T cells. And this was developed by a very talented postdoc, PhD, and then postdoc from my lab that now she left the lab, she's in Germany. And we started with a very simple question. So what happens if you just remove this receptor A2A from regulatory T cells? Okay. So we crossed FOXP3 Cree mice with A2A receptor floxed mice, and then we were expecting to have some spontaneous inflammation or even some scurvy-like phenotype, but for our initial disappointment, what we found that was these mice were normal. So they breed well, they didn't have any acute signal of inflammation. Then we did some experiments acutely, and we didn't find strong phenotype in these mice. Then something like 1 year later, or a little bit more than 1 year later, the responsible for the animal house there in Ribeirão Preto called us to change and then to change the breeding pair. And then when my student went there and she looked at the breeding pairs, she noticed that these mice were a little bit smaller with some signals of skin inflammation. Then we took tissue cells, lymph nodes from these mice to analyze what was happening in these mice. And what we found was when these mice are young, we don't see too much difference. But when they get aged, so the elderly mice, we can see very clear that they develop, they have anti-nuclear antibody. And then we also measured the anti-DNA antibody, and it's very clear that these mice have very high levels titer of anti-double-strand DNA, reminding or suggesting that these mice might have lupus like autoimmune disease. We also look at the kidney, so for the deposition of immunocomplex and the renal glomeruli, and we can see that in control mice, when they get aged, we can see some deposition that's normal of some immunocomplex, but in these knockout mice, specific for the receptor regulatory T cells, we can see even when they are young a little bit, and a massive deposition of immunocomplex when they get old. So, and then we started to evaluate the immune system of these mice, and then we looked for general activation and the memory state of these cells, of T cells in these mice, and we didn't see any difference when they are young, but when they get old. So when they get old, we can see a very high amount of activated memory T cells and reduction of naive T cells. And we also looked for regulatory T cells, of course. And again, when they are young, we don't see too much difference. However, when the knockout mice, they get old, we can see even high levels of regulatory T cells, suggesting that the differentiation and probably proliferation of regulatory T cells were not affected by the lack of this receptor, but probably the function of these cells was affected. And then, so what we found initially was that the lymphoproliferative disorder, they develop a lymphoproliferative disorder, despite they still have high levels of regulatory T cells. So to understand a little bit about the role of this receptor in the differentiation, proliferation of regulatory T cells, we crossed these mice also with CD4-CRE, so to have all CD4 knockout and to do in vitro differentiation of regulatory T cells. And we did a curve of the TGF-beta to see differentiation, and again, we don't see any difference. So reinforcing that this receptor is not important for the differentiation and for the proliferation of regulatory T cells. And then we did a suppression assay where we isolated cells from aged mice or for young mice. And then we did a co-culture with responder cells from young naive mice. And then what we found was that regulatory T cells from these mice that are deficient in the receptor, they are, so the cells are not able to suppress, or they are deficient in the ability to suppress like white type cells. So, the partial conclusion is that the reduction of suppressive ability of regulatory T cells might explain this phenotype that we found in aged mice. So I said to my postdoc, great, we have a very interesting project to go further now. And she said, well, no way. So I needed to wait 18 months to do the second experiment. So how can I survive? How can I keep my fellowship? And then we decided to use an autoimmune model that we used before, and we didn't found phenotype that was exactly the EAE. So the experimental autoimmune encephalomyelitis. I just swap here because of the time, but just to explain this model, we immunize the mice with a peptide from the myelin peptide, and these mice, they develop a phenotype that reminds multiple sclerosis. And then we just adapted this model to explore the role of HA receptor in regulatory T cells by using a suboptimal condition of the model. Because when we used a normal protocol, a normal model, we didn't see differences. So what we did, we immunized the mice with the lower amount of antigen, and the protocol was reduced. And then we can see that the control mice, they developed the disease, but a mild disease. And then in this context, we could see a very increased or a severe model of the disease in the knockout mice. So even some mice also died by this model. That's not common. Then we look at the periphery of these mice, the immune cell in the periphery, try to see the role of Th17 cells, because these cells are the most Th subtype involved in the development of the EAE model. And we can see by performing a recall protocol that there is no difference in the generation of Th17 in the periphery. So, but we look at the inflammatory site in the spinal cord and the brain, and then we can see very clear that we have much more Th17 cells and even cells producing interferon, suggesting that this might explain why these mice develop a severe form of EAE. And when we look at the regulatory T cells, again, we saw that these mice, they have much more regulatory T cells, despite they have more inflammation. So to understand, or to explore the potential mechanism involved in this process, we look at we decided to do single cell RNA-seq, isolating CD4 T cells from the spinal cord of mice after immunization. So we induced the disease, and the peak of the disease, we assorted CD4 T cells when we did RNA-seq. We did in Ribeirão Preto in collaboration also with Leandro Colli, and also with the help from Elder Nakaya for the analysis of the single cell data. And in an unsupervised clustering analysis, we could identify 11 different clusters of CD4 cells that infiltrate in the spinal cord. And by doing a bias analysis, trying to understand, to look some specific genes related with pathogenic Th17 cells, we found that this cluster on the top, the cluster 3, is the one where the pathogenic T cells are located. On the other hand, the genes related to FOXP3 were in the opposite way here in the cluster 2, expressing specifically FOXP3 and CTLA4. So we compared later what happened with cells isolated from wild-type mice and from knockout mice. And for our initial disappointment, we didn't see too much difference. But after a further analysis, what we found actually, so we look at first for genes related to Tregs, so FOXP3, CTLA4, and GIT1. So what we found is that actually knockout cells, cells from knockout mice, what we see is a small population here with a weaker expression of these genes compared with the wild-type mice. When we look at the opposite, when we look at the genes related with Th17, pathogenic signature, we can see very clear that the cluster is on the top. And for example, the HOR alpha, that's a transcription factor, is spread between the other clusters. But what we found when we look at the knockout mice was that these genes related with the pathogenicity of Th17 cells, they are, so the intermediated cluster is expressed at higher levels compared with the knockout mice. We can see very clear here in terms of HOR alpha or the iron receptor, but we can see also for other genes related to pathogenicity of Th17. And then discussing this data with the elder, he told me that, well, maybe we can do another analysis that is the trajectory analysis. So the pseudo-time trajectory analysis, where we can see if the Treg population would be connected somehow with the pathogenicity. And what we found was that the analysis suggested that there is a potential connection between the cells that are regulatory T cells, and they can acquire pro-inflammatory phenotypes and become pathogenic Th17 cells, suggesting that what we have in the deficiency of regulatory T cells is the reduction of stability, and this consequently affecting the function of regulatory T cells. So we validated this data. I don't have unfortunately time to show all the data, but we sorted again CD4 T cells from the spinal cord of these mice, and we look at specifically, for example, for IL-17, that's the signature of pathogenic Th17 cells, and we can see very clear that regulatory T cells isolated from knockout mice, they express high levels of IL-17, but this doesn't happen in the periphery. So this was a very interesting result, because tell us that maybe regulatory T cells in the hostile microenvironment, where we know that we have a lot of pro-inflammatory cytokines, HOA receptor would be a receptor important to maintain the stability of T cells. So we did another approach where we used a fate map strategy. So apart from the initial crossing, so the crossing FOXP3, Cree mice with the HOA receptor mice, we also used another reporter mice, that's tomato, that's controlled by a stop codon that were fluxed. Meaning that when we cross these mice, okay, all the regulatory T cells, we also acquire a yellow color and also a red color. But if the cells are expressing in that time FOXP3, they are the positive. But if they express it in the past FOXP3, but they are not expressing anymore, they are just in a red color. So with this protocol, we can see a fit map of these cells, and we can say that these cells are X-Tregs. And we did this experiment. We immunized again these mice. We isolated CD4 T cells from these mice, and we isolated only the X-Tregs, okay? Cells that express in the past FOXP3, and also they are wild type and knockout mice. We can see here post-sorting. And then what we did, we activated in vitro these cells to see if these cells are acquiring a pathogenic phenotype. And this was exactly what we found. So we can see very clear that the cells that were Treg in the past, when we activated in vitro again, so they started to express IL-17 and also double positive expression with interferon. So what we concluded with this data was that HOA is very important for the maintenance of stability in a hostile microenvironment. However, in the absence of this receptor, these cells lose this lineage stability, the suppressive activity, and also they become pro-inflammatory cells. So to explore a little bit about the mechanism, and I'm finishing in 5 minutes, we
try to reproduce this in vitro, and for this we created what we call it a stability assay in an inflammatory milieu. So we isolated CD4 T cells from these mice, immunized mice, and then we activated them in vitro with only TCR or in the presence of pro-inflammatory milieu or pro-inflammatory cytokines, trying to mimic what's happening in the spinal cord of EAE mice. And this is the pore sorting to show that we have a similar amount of cells. And after 3 days of culture with TCR activation, we saw this is well described that we have a reduction of FOXP3, but the reduction was similar between wild-type mice and knockout mice. However, when we used the second protocol, so with the pro-inflammatory cytokines, we could see that wild-type cells maintain the stability. Okay, so they were not affected by the inflammatory cytokines, but when they don't have the expression of HOA, they reduce the FOXP3 expression, and they also start to express IL-17. And this is we can recapitulate this by looking the release of pro-inflammatory cytokines, especially GM-CSF. That's a cytokine well described to be involved with the pathogenicity of Th17 cells, and this we don't see in the wild-type cells. This is not a problem related to the deficiency or some genetic problem of these mice, because we can recapitulate exactly the same phenotype by only add the antagonist of HOA in the culture of wild-type cells, and again we can see a reduction of FOXP3 expression and expression of IL-17. So what we have in this conclusion is that regulatory T cells are, when they are in a microenvironment where we have pro-inflammatory cytokines that are pushing pushing the cells to reduce the stability and to reduce the expression of FOXP3, the regulatory T cells, they are able to be protected because they are able to produce by themselves adenosine, by this pathway well characterized, and then in an autocrine or paracrine loop, they are able to sense adenosine in the microenvironment, and then this is affecting, so they're blocking the ability of pro-inflammatory T cells to reduce the stability. So, but how this receptor is able to do that? So we are now in the process of exploring the mechanism. I will just show some very preliminary data where we try to rescue this phenotype by giving exogenously cyclo-MP, and what we found is that first of all we measure cyclo-MP, and then in the presence of the pro-inflammatory cytokines, control cells, they express cyclo-MP, but this we don't see when they don't have the receptor. And then when we activate adenylate cyclase, we can rescue the ability of T cells to produce cyclo-MP, and they are more protected, and we can completely or partially, but importantly, rescue the ability of these cells to maintain the expression of FOXP3. So cyclo-MP is important, and but how cyclo-MP is important, it's controlling this process. So we choose first to investigate the role of STAT3, because we know that IL-6 and IL-23, they signalize via receptors and then activate STAT3. And we looked for the phosphorylation of STAT3 in these cells, and we found that when we activated regulatory T cells with IL-6, we can see higher phosphorylation of STAT3 in knockout cells, suggesting that for some reason cyclo-MP is blocking or reducing the phosphorylation of STAT3. So our working hypothesis that we have now is that the signaling of H2A receptor in regulatory T cells does not affect the differentiation of regulatory T cells, but is important for lineage stability and consequently for suppressive activity. And this is important, and it's related to the production of cyclo-MP and the blocking of STAT3 activation. So this is my group. I have to acknowledge who did the hard job in the group. Daniela was the postdoc here that did most of these experiments. Now she left. She's in Germany doing another postdoc, and also the collaboration with all the colleagues, especially now the colleagues from France that are also involved in the process. Thank you for the attention.
Thanks for you all, the very precise and complete and really interesting presentations. We have some time for discussions, both scientifically or about our cooperation tools.
It's fine. Yeah, no, thank you very much. Look, it was a scientific question, you know, maybe others will come later, but Doc, I think you showed very nicely a role of this receptor in the Tregs, in this mouse model, and I'm wondering, because I work a lot with different autoimmune diseases or inflammation, and often in the context of inflammation, you do have much more Treg cells, either in the tissue, and for example, even like in type 1 diabetes, we can see the Tregs are abundant, but they cannot be suppressive anymore. Look, I think, have you some data in human to see what is the status of expression of this receptor in the Tregs?
Okay, that's the important question. We have some data of human cells as well. We know that human cells are also express this receptor, and we could recapitulate most of the in vitro data that we just showed with human cell, the regulatory T cells also differentiating in vitro. But what we don't know if we could translate these results that we found so far for the autoimmune disease found in humans. So this is something that we need to do in the next step to submit this paper.
Great.
Thank you.
More questions?
So thank you very much for the brilliant presentation. So my question is to Nicolas. Can you comment a bit on the role of STING in epithelial cells, maybe in the IPF model?
So using our STING reporter mice, we also looked at non-immune cells and epithelial cells, and we do have expression 82 cells, and it's something that we would like to explore. And Zeka has some STING flux animals, so maybe the idea is to, at some point, cross them with surfactant protein C or other. And also in the SAVI mice, so the gain of function mutation, people have shown that STING expression on the tumor cells might be critical. So for sure, it's expressed in many cell types, but neutrophils, that's the also really thing. But epithelial cells for sure, yeah, they do have a role.
Hello. This is a question for Livio, actually. So I'm Alexandre Bocato. I'm from FAPESP. I take care of some of our international collaborations, especially with France. So welcome you again here. So just to mention that FAPESP and CNRS have already collaborated, especially in the Sprint program for mobility of researchers from São Paulo centers in France. So could you please comment a little bit how CNRS is inserted in universities? Because when we see the short bios of researchers in France, we always see a number, CNRS, sometimes the name of the center, but seldom the name of the institution. sometimes we can dig in and find the name of institution. How does that work? So people understand more how the CNRS is inserted in universities in France.
That's a very good question. Actually, CNRS is not inserted in the universities. We are co-administrating laboratories in France. So there are two kinds of laboratories, what we are calling only owned by CNRS laboratories. These are, let's say, 30 of them actually. On the 1,000 labs, only 30 are administrated only by the CNRS. The other ones are co-administrated with universities, engineering schools, and other research organisms. So if you are looking about the affiliation of one specific researcher in one specific lab, if you want to know if he is CNRS he or she CNRS researcher or researcher of one university or another, it's like digging in the database of the lab in order to know who is affiliated to who. But the fact is that the affiliation is who's paying who, right? So if he or she is paid by the CNRS, you're gonna see a CNRS researcher or director of research, and if not, they are professors, or what we are calling associate professor is maître de conférence. Even for us, it's difficult. So you know, that's my simplest answer.
More interventions? Well, I can maybe add some information just to say from FAPESP's point of view that we decided, we will announce this more precisely in probably next month, but we decided to launch a special program to support this more institutional initiatives of creating international centers in institutions of research in the state of São Paulo. For instance, the case of this international research center with CNRS in the University of São Paulo, and another example in the University of São Paulo, Institut Pasteur de São Paulo. It's an association between Fondation Pasteur and the University of São Paulo. For this case, FAPESP will organize a kind of a fast track or a special budget separated to demands coming from these centers. It will be with the same tools that FAPESP normally uses. So it's jovem pesquisador, young researchers, fellowships or postdocs, or PhD fellowships, or regular or other kinds of support for research projects. But with a very special addition, that's the possibility of a researcher from, in these examples, CNRS or from Pasteur, based in these centers, even though not officially, not formally linked to the University of São Paulo, being considered eligible to submit proposals directly to FAPESP. So it's something special to attract and to stimulate our partners based in São Paulo to be to take these initiatives of reinforcing the partnership through their own projects, demanding directly to FAPESP. That, I think, it's a very important and new initiative to strengthen this kind of partnerships.
really enjoyed your talk about sting. I have a question. What is the role of sting, you believe, that in the bleomycin-treated mice that induce fibrosis, right? Lung fibrosis artificially by drug, right? So you believe this sting is increased in this intermediated myeloid cells to dump or to aggravate the disease, right? Is a causal consequence, is also because you postulate that this thing play an inhibitor role, right? Since the beginning. So is this because it's increasing what we are thinking? I know you just search for mechanisms, but it's not still clear what to do.
Yeah, no. So we've done kinetics, and we don't have any difference between the wild types and the sting knockout animals during the first week. So it's not in the early inflammatory process that sting is displaying a role. So it's more in the control of inflammation or resolution of tissue damage. And our hypothesis is that macrophages, upon stimulation by DNA from the host, is having a different effector program that can control fibroblast differentiation, extracellular matrix proteins secretion that would lead to fibrosis. So if you don't have sting, you don't have this layer of control, and you have more fibrosis. That's the hypothesis.
Thank you.
That's all. So thank you again. Thank you very much. My congratulations. Now we'll have. You are all invited to lunch here, and I would suggest you not to leave your belongings in this room. And we'll be back. We'll be back next panel 2 o'clock here, the same room.